this video, we're going to cover the basics of wiring, starting with the simple wire. Most all the wire that you're going to find on the car is the multi-strand wire, as compared to a single strand wire. In household, they use almost exclusively the single strand wire. In the car, use almost exclusively the multi-strand. There's two advantages to the multi-strand. One, it'll handle being flexed around without breaking. Two, for the same size wire, it will have less resistance. Electrons like to flow on the surface, and multi-strand has a lot more surface to it. There is a lot of single strand wire that you're looking at these two images down here. Those are used in electric motors, solenoids, relays, alternator, places like that, where they don't have to flex. Other type of wiring that you're going to find is secondary wiring that you're looking at right here. And this is your plug wire ignition system. Secondary is going to be used for high voltage. Wire sizes. Right hand side, we're looking at AWG, which is American wire gauge, which is backwards. If you do any shooting with a shotgun, you'll know that a 12 gauge shotgun is a larger bore than a 20 gauge shotgun. American wire gauge is the same. Larger the number, the smaller the diameter wire. This one goes all the way to a 2. In the automotive side, if you get to heavy duty truck with a diesel engine, you may find like a double-aught wire in there. On the automotive side, on the light duty, you're going to find like a 8 to 4 gauge, somewhere in that, for a battery cable. Most of the wire that's going to be used on the car is in this range right here. Back in the 70s, a lot of the wiring was 14, 16 gauge. Most of the wiring on the cars today is 18 to 20 gauge. However, the way that you really need to learn it is you need to learn the metric system. So I'm there showing you wiring diagrams. If they show you the size of the wire, they're going to show it to you in metric. Decimal point doesn't really show up. This is a 0.22, 0.35, 0.5, 0.8, and then we get to 1.0. Most of the wiring on today's cars is a 0.5 millimeter to 0.8 millimeter. This chart on the lower left here is if you're doing your own wiring. If you're going to add a component to the car, or if you're wiring something on a trailer, you need to figure out how many amps, how long the wire needs to be, and that's going to tell you what size wire you need. This one column right here, you're looking at 5 amps. If it's going to run for 40 feet, it needs to be a 2 millimeter wire. Over here you can see if we have 20 amps and only 10 feet, again, a 2 millimeter wire will work. If you were to put a 1 millimeter wire here instead of a 2 millimeter wire, it's still going to work. It's not going to burn up anything. What you're going to end up with is too large of a voltage drop. The reason that you're going with the size of wire is you don't want an excessive voltage drop. To give you an example, if you're using an incandescent bulb, a 10% voltage drop, 1.2 volts, and that light bulb will be 30% dimmer. It's not because of burning the wire up, it's because you're wanting to not have an excessive voltage drop. When it comes to making wiring repairs, these connectors are a really good way of doing it. These are butt connectors. You see the 3 different colors, and they're 3 different sizes. The yellow is for 3 to 5 millimeter wire, the blue 1 to 2 millimeter wire, and the red, which in this is kind of a pink or salmon, is 0.5 to 0.8 millimeter. You're going to use the correct color for the size of wire that you have. And we'll talk about putting them in there and crimping them correctly as we go through the next few slides. Another type is the spade connector. When you go to buy your spade connectors, the female versus the male, I typically buy them in bags of 50 to 100. And I will buy twice as many female as I do male, and I use a lot more of those. Just an example, if you're putting in a relay, the relay didn't come with the wiring, you're going to use 5 of those female ones and not a single of the male. The ones on the bottom there is the same spade connector, but it has the nylon instead of the plastic. That's one of your indications of a good quality one versus the cheap one. I want to come back to these butt connectors. These butt connectors are actually the top of the line. These are the best ones that you can get. If you look at the metal crimp inside there, you'll see that there's no seam that's on there. It's just one piece. The coating of nylon coating that's around there is actually a shrink tube and has a gel coating on the inside. So after you get it crimped, use a heat gun, melt that down, and it'll make an environmental seal, and it's a very strong connection. When you're working under the hood or under the car, you want to make sure that you're repair is environmentally sealed. If it's under the dash, you don't need to worry about the environmental seal. Well, this is an eye connector or a ring connector. You can see on the bottom image that there's multiple different sizes. If you're going to use these, make sure you get the size that you need. And you can look right up here and you can see that little seam right there. We're going to come back and talk about that a few other times. Here's the tools, and we have the good, the bad, and the slow. I'm going to start off talking about the slow, which is this one here. You can see on the end there, it has the yellow, blue, and red. So whichever color connector you're using and the right size wire, you're going to stick it in the slot there. This has a ratcheting handle, so as you crimp down, it's going to put exactly the right amount of tension. When you crimp it, if you have too much, it can actually cut into the wires and add resistance to your circuit. If you don't have enough, the wire's going to pull out. And even if the wire doesn't pull out, it's not going to make good contact. The bad, which is this style here, when you go to buy a box of connectors and it comes with a free crimper stripper, I think I said that right, throw that one away. If you buy one like this, make sure you get a good one. It's a little bit thicker metal. The edges right up here are rounded off, so those cheap ones just have a sharp edge that will actually cut through the insulation as you crimp it down. The other thing is, on the cheap ones, the stripper part right here, you're supposed to put the wire inside there, crimp it down, it'll strip. Most of them will not strip the correct size wires. It gets very hard to strip with those. This one over here, guys that do a lot of wiring, this is the tool that they're going to have. It has the crimp part right here. It has a wire cutter, which they use to strip. On that part right there, you have to be very careful when you're using a cutter to strip because it's real easy to cut through the strands of the wire. Now, when you go to crimp, you'll notice that this part right here is lined up directly with that seam that's on there. It has to be exactly that way. In this video, we're going to show you a good stripper. So this is a one hand. You can get these at most any hardware store, and they will get in there. The other advantage to them is they can strip a wire right in the center of the wire. So if you buy them from the hardware store, check it out, give it a try, and you usually have to buy 2 or 3 of them before you get one that works really good. Here's one that we have that is crimped correctly. You'll notice that there's a gap right in here. When you strip that, or when you go to crimp it, there needs to be that gap. If the insulation is right up against the steel part there, it's going to act like a fulcrum and try to pull those wires out. You also don't want it coming too far out here, because when you put the screw in there or the nut, it's going to tighten down on those wires, not on the connector itself. So again, pointing out that that crimp needs to be right on top of there. When you get done taking a look at that right there, that's what you want that to look like. It looks kind of like an M, but they'll refer to it as a W crimp. That's going to hold tight. This one I did purposely wrong, and you can see what happened from that seam. It just crimped in there. It is not going to stay in there. That's eventually going to pull out. The other thing that I purposely did wrong is I put the insulation right up next to the crimp. This is the right way to do it. This is definitely the wrong way to do it. Now, getting to the manufacturer's connectors. First one we'll talk about, just real quickly, the molded connector, which is this one right here. If you're working on something and this is corroded, melted, something's wrong with it, it has to be replaced. There's no repair, nothing you can do with those molded connectors. Fortunately, not too many of those. This is the style of your typical connector that you're going to find on the manufacturers. They got the terminals that fit inside the connector, and then they have this seal and this seal. Those are environmental seals, and they are amazing on how good of a job they do. Back in the early 80s, GM had some coolant temp sensors that didn't get soldered correctly, and they started leaking internally. The coolant pushed into the connector and right through the wire and dripped coolant onto the motherboard in the computer. I've seen other cars that a fuel pressure sensor or a fuel injector leaked internally, and it leaked fuel inside the vehicle because on those cars the engine computer was still under the dash. They really are a good seal. If these terminals get damaged, they can be replaced. Not easily, until you get used to it. One of the things I want to point out, this metal part right here provides the tension when the male terminal goes up inside of there. Push it in there once, take it apart, push it in again, keep doing that several times, and this is going to lose tension and then not make a good connection. At that point, this needs to be replaced. When you go to replace these, the crimp on these is better. This part right here is referred to as the core crimp, and this is actually going to crimp around the strands of wire, and you're going to use a W crimp. So it's going to fold those in, and they're going to look like that, nice and tight. This part right here is an insulation crimp. Moving back to take a look at this, so that gap right there, when this wire starts flexing, that's where it's going to flex the most. On these, this is going to act like a strain relief because it's going to be crimped around the insulation of the wire as well. Here's some other types. Packard makes a lot of the connectors for the automotive industry, and they have MetroPack, MicroPack, WeatherPack, PackCon, and then manufacturers make their own. They can be repaired. You just have to figure out how to get the terminal out. This one right here, that's little metal tabs. You have to stick like a pin up inside of there, push that tab, and then you can pull this piece out. Some are push to seat, others are pull to seat. Taking a look at that white piece there and this gray piece here, and on this one, unfortunately, they made it the same color as the connector, but those are what they refer to as a secondary lock. There is no way you're going to get those terminals out of there until you get the secondary lock off of there, and then find whatever piece is holding that inside of there, get that pushed out of the way, and then you can get the terminal out. If you've never played with those, go find a wiring loom somewhere, where you go to a junkyard and cut some ends off and practice with that. Because if the first time you're doing it, you're laying on your back underneath the dash, you're not going to be able to figure it out. This one is a bulkhead connector, so same type of terminals. They can be repaired or replaced. Or not repaired, but they can be replaced. On the bulkhead connector, one side of the connector is going to be under the hood. The other side of the connector is going to be under the dash. There's going to be a hole in the firewall, and this is where all your terminals go through. Or not all of them, but a lot of them. Older vehicles had one. I've seen as many as 3 bulkhead connectors on some of the newer cars because we have so many wires running on the car now. Here's the tools for getting these terminals apart. This is the least expensive one, and it'll do a lot of them, not all of them. Your next one would be this one here, which I've never tried that one, so I don't know. This one right here is my favorite one. It comes in a molded case and has a whole bunch of different terminals, and I've been able to get most all the connectors apart with this kit right here. We also have our printed circuit. If you work on the older vehicles, this was the type of printed circuit that they had on the back side of the dash. It makes a really confined way. Instead of having a whole bunch of wires, they just have this piece of plastic and the wires are literally printed on there. You do need to be careful with these. It's not like you can't touch them. I've touched them all the time. You just have to be real careful. This is the spot where the dash lights are going to screw into there. It's a 90-degree twist. You have to be really careful because this is real thin, real flimsy, and if you have it bent over wrong, it'll damage it, then it needs to be replaced. This style is what the manufacturers have gone to because your IP now is a computer. And that's a computer that's going to communicate with multiple other computers on the car. The light bulbs, where you used to be able to replace the light bulbs on these, a lot of newer ones, you have a bulb burnt out, you got to replace it, or if you have the ability to replace the light bulb yourself, otherwise you're replacing the entire instrument panel. So that concludes this video. Hope it was helpful.